This is just spending communication I played on you. Yes, I can manipulate reality.
Okay, so couple of things. I did not grade the test yet. This is my 6th week in my class, which means that the big paper is due tonight. And in this class I had an assignment which took me about 15 hours to do, plus I had to write the paper, and I didn't actually even walk out of my house yesterday. I wrote all day long in the chair, sat in the chair most of the day, writing.
Is your back?
And it's not done yet. What? And the problem is that I'm writing it on what's called a CAFR, which is the Comprehensive Annual Financial Report for the state of Tennessee, which is almost 300 pages long, and I have to find numbers for different things, finances.
There has been a fire alarm reported in the building. There has been a fire alarm reported in the building. Please proceed to the stairways and exit the building. Do not use the elevator, but proceed to the stairways and exit the building.
procedures and students, you may now return to the building.
What?
It's not.
No.
If you put that email before you were supposed to.
Right next to me. Zoe has a whole line.
Good thing, just talking about this. Hey,
I love
you grab it. What's the meeting tomorrow? What's the one that just grabbed you?
Oh.
Very cold. Let me.
Okay, the other thing.
So kill me.
The other thing that I wanted to say was about the test. I think it was a little hard too, so take that in consideration when I look at them. Okay, I think I ended up maybe a little hard, but I don't know.
Yes.
We'll see. Okay, so today we're gonna do 16.2 and 16.3. But before we get out of the book, just hang on a second. How do I find the circumference of a circle?
Pi times something. Pi r squared. That's area. Oh yeah, that does sound like
Pi
area to
d,
me.
pi
Pi d.
times the diameter. Pi times the diameter.
Okay, yes, or 2 times radius, right?
Yeah.
So what is the circumference of the circle?
That's 16.
16.
Okay, 16 pi. And pi is a number, and you can leave it. Okay, a lot of times they'll tell you to leave it in terms of pi. Okay, so sometimes it'll ask you that, and I don't care if you multiply it by 3.14. Actually, I prefer the pi button on the calculator, but a lot of times in the homework problem, if you're matching your answers to the book, and they might tell you to use 22 divided by 7, okay? So just keep that in mind when they're doing that. Now I want you to tell me how I find this length.
It's a.
By knowing okay, so the center angle is 90, and I can say that that is a 90-degree arc, but I'm asking you for the measure of it.
Ooh.
Okay? Yes.
Wait, is it like a fourth of the circumference?
Okay, yeah. So arc length Okay, when I'm asking you for the arc length, I'm asking you for the measurement, and in this case, it'd be 1/4 of 16 pi, right? Does that make sense?
Yes, ma'am.
Where'd you get the 1/4 from?
It's like you're looking at the top of the circle, so it's like that, like the circumference.
1/4 of the circle. So what if I did? Let me draw a new circle.
Oh.
I don't know what that was, but it sounded gross. Okay. What? What about the arc length from here? to Here.
That'd be
Yes.
1/3? I can't see the number.
No.
No, 1/3 would be 120.
Yeah. You feel me?
so it'd be like.
How did I just figure that out?
Because 360 divided by 3 is 120.
Oh.
Okay, I'm giving you a hint here.
Yeah.
360 divided by 125.
Oh, what would that be?
No, 125 divided by 360. Okay,
25 divided by 360.
so you want the percentage of this arc, right?
Oh.
So what I'm doing is 125 divided by 360 times 16 pi, right? This, you skip to 1/4. But do you see that this is really 90 over 360?
Yeah.
Does that make sense? Okay? So the formula in the book, wants to do this.
Tomorrow.
Arc length. I was trying to look at the, equals M over 360 times 2 pi r, okay?
Ms. Sharp?
Yeah.
Can we take a picture of that once you're done?
Yes.
Thank you.
Shulk is an absolute unit, don't at me.
Oh, I'm in sector area, that's why I'm not finding it. Okay, so, and they use S for arc length. Okay? In fact, do they use 180? No? Okay. So do you see how you find arc length?
Yes. Dude, the stream.
So that's how you find arc length. Okay? Now I'm gonna do area. I'll just pull it up, a blank page up here.
Honestly, I want to make it.
Okay, so if I have a circle, a radius of 8, how do I find the area of that circle?
Pi r squared. Yeah.
Okay, so area equals pi r squared, So I get- pi 8 squared, which is 64 pi, right?
Sure is. Correct among them.
So now, what if I want to find the area of this sector right here?
1/4. 1/4.
Okay, it would be 1/4
Boom.
It would be 90 over 360, right, or 1/4. Which is 4 is 118 5. Okay,
18.
all right.
Cool.
So what about if I want?
How would you know if it would add? Oh, it's 90 degrees. How does it figure it out?
Yeah,
I
it's
get-
90-degree angle.
Where'd you get the 64 from?
Yeah, but she's put basing. it
8
off the
squared.
back over there.
8 squared, right?
I guess.
Marissa, throw back to fifth grade, sixth grade.
Okay, so now what about in this circle? If I want the area of this sector, and this is a 160 degrees, how do I find the area of that?
160 over 360.
Okay, so we call this sector area. And it's 160 divided by 360 times pi r squared, which is I don't know what that is. What's 160? Let's see, 160, I can figure it out.
160 divided by 360.
Yes,
0.444.
times 64.
Times 64. 28.442.
28.45.
Yeah.
Well,
Okay? Now, arc length, okay, sector area, it's not bad, is it?
No.
If you know your circle area formula and if you know circumference formula, these two things are not hard. Okay?
I'm gonna take a picture of your chart.
Yeah, can we take
Alright, yeah, go ahead and take your pictures. Okay. So, now you can open your book. I just taught you 16.2 and 16.3.
How did you do that? How can you do that without do that in like 5 minutes?
I know, right? The book wants to make it a big deal, okay? And they want to show you this strange looking formula, but it's not. It's just simply
Easy and simple.
What page?
a percentage of the circle.
What page?
So if you look on page, look at page 865 for a minute. We're not doing a problem. I just want to show you this picture.
Wait, what page?
865. Now, I want to show you a picture of concentric circles. Okay, whenever you hear the word concentric circles, it just means they're inside of each other. And do you remember when we were talking about the arc measurement? It's the same as the central angle, right? So this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees, right? But are those arc lengths going to be all the same?
No.
No. So do you see where the difference in it? Okay, they're all the same percentage of the circle, They're all the same percentage of the circumference, but the circumference is going to be different for every one of them, right? The area is going to be different for every one of them, right? Okay? Okay. So now, come on, you guys. 866. Radian measure. I need to, oh, you guys. Can we just get it out? Say whatever you need to say.
I need to get the snot out my nose. Can I do that right now?
Every sentence I start, you guys are talking to each other. I have to wait or shush you. You guys see what you're doing, right? I mean, nobody in here thinks I'm crazy, right? You guys, every time. You guys, every time. So, if it's not you, it's you. 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 Do you see what I'm saying? If it's not you, it's you. If it's not you, it's you. It's so rude. Please stop. Radian measure. Okay, remember in your calculator it has degrees in radian? Remember when we were doing sine, cosine, and tangent? I told you had to make sure it was in degree mode and not radian mode. Degree is radian is that outside. Okay, and it's really hard. How many of you have had algebra 2? You two. You've had. Yeah. Okay, so it's really hard for me to explain the radian measure in the depth it should be explained. Okay, so what I'm going to basically do is tell you about it and tell you, but I'm not going to tell you why or where you'll use it. And it's really hard for me to do that. So what I want to do before I show you this is how many degrees all the way around the circle is it? 360. Okay, so 360 degrees. Halfway around is 180 degrees, right? A quarter is 90, and 3/4 is 270. Y'all know that already.
Yes.
So, this is 1/2 pi, and pi is halfway around the circle. 3/2 pi is 3/4 of the way around, and all the way around is 2 pi. Okay? And you use this, well, it is a pi symbol there. You use this in algebra 2 when you do unit circle stuff. Okay? And you can do a lot of the sine, cosine, and tangent without actually a calculator if you use a unit circle. Now, so when I'm talking about radian measure, I'm talking about those pi's. All right? So if I want to say 90 degrees, it's also equal to pi over 2, 1/2 pi, okay? So when you're radian measure, that's what those answers were giving you, is it using those other numbers, the numbers in blue. So the way I'm going to show you guys this is that if I have a degree measurement, okay, for me to change it into radians, I'm going to add a pi and divide by 180. If I had 60 degrees, I add pi and divide by 180. And think about it, 60 degrees is about here, isn't it? Is 1/3 pi less than 1/2 pi? Yes. Okay? If I have radians, okay, and this is what I also say, is I'm going to take away the pi. I'm going to get rid of the pi because we don't use pi in degrees, do we? Have you ever heard the temperature was 80 pi or anything like that? No. Okay? And degrees are a bigger number than radians are. Do you see that? Degrees are a bigger number. It goes from 1 to 360. Are you guys just gonna let it go?
April Fool.
The phone call was April Fool's?
No, we all set alarm for 9 o'clock.
All of them were going off.
Yeah.
You thought everybody had a phone call?
I was like, who's calling? Well, I didn't hear every phone. I just heard like one loud one.
Which one you hear?
And then when you turned yours off and you didn't, I thought, okay, it was yours, not yours. So, okay, it's hard to play an April Fool like that on a teacher that can't hear. Like, it's like one.
We thought about that.
I was like, well, and plus I don't get mad at phones going off. I was getting a little irritated that you were shutting it off, but I don't get mad at phones. That's good. Pretty good, you guys. Is that what y'all were having whispering about? Oh my gosh! Y'all were about to drive me crazy with it. Come on, good. That's funny. That's funny. Oh. I'm like, the best part of that was the fact that y'all been whispering about it, and it was driving
Well,
me
I
crazy.
was like, hey, playing my view off is mad.
Yeah, I got scared. You got
No, the hardest part, I thought Jonathan was gonna say something to you.
Oh,
That's what I was thinking.
that's
Be like, hey,
that's funny.
at this time.
All right, you guys got. Hey, I have to tell you that this was the first time a class has played an April Fool's joke on me.
Well, it was my idea.
Was it? I can't believe now I think about it. I can't believe that nobody's ever done that before. I've done something, you know. I can't believe nobody's ever done something before, but that was fun. Okay. All right. So if we've got a big number, we're going to divide by 180. If we've got a little number, this is how I remember if I'm dividing or multiplying by 180. If we've got a small number, we get rid of the pi and we multiply by 180. And I don't know what that is. 3/4 of 180.
$135.
Okay, do you see? Radians to degrees, degrees to radians. All right? Oops. Okay, so let me ask you right now. If I want degrees, if I've got radians, what am I going to do? If I've got radians and I want degrees, what am I going to do? Multiply by 180 and get rid of the pi.
Oh, that.
Right? Yeah, if it doesn't have pi, you're adding pi. If it has pi, you're getting rid of it, right? And then you just have to remember to multiply or divide by 180, okay? That's it. That's funny. Okay, that's all I got.
I was like a nurse copy and a copy put it down, Steve.
And I haven't done an assignment sheet yet. Okay, so. Oh, look at number 10. Let's look at number 10.
Suppose you're doing this.
The circles are concentric. Find the length of PQ. So I'm gonna put an X there. Is everybody there with me?
Say that again?
Number 10 on page 868.
Find the length of PQ. Get me five. Find the law. Oh, it's going off again.
It's off.
Yeah. We had to dismiss it, I forgot to do that.
Alright. So it's this is where's that K supposed to be? Okay. Okay, so all of this is a ratio. And so in this case, I know 30 is to 2.5. As X is to K. Okay, wait a minute. I know why I didn't do this. I thought I had marked it out because I wanted to do it with you, but they're missing a number. Alright, so we're not doing 10. Oh, 9. That's the one. We're supposed to do 9. Sorry. Same thing. Alright, so find the length of this one. Okay, so 8.7 is to X as 10 is to 40. Okay, the length of the arc, I can also set it up as small is to small as large is to large. You see they're the same,
Yeah.
right? But that's just how you would solve a problem that looks like that. Does that, right? I know that this to this has to be the same as this is to this, okay? All right? Because I think that's the only one like that.
Wait, so what did you?
No. I'm gonna, what?
So would you multiply 8.7 times 40 and make
10
it equal?
10 times X and then divide by. So you're gonna have to use proportions in a couple of these problems, which is why I wanted to show you that.
I think I understand.
Yes.
So wouldn't the answer just be at 8.7 times 4, basically? What's softly?
Is that right? Yeah. Okay? So you'll have to do some proportions
It's been
in here with the concentric circles, right? Alright, so problems. You are doing,
Now.
alright, let's look at 1 through 3. I have 1 through 3. Let's do 1 through 3 together. What part of the circle does the expression 2 pi r represent?
Oh, the circumference.
Circumference, yes. What part of the circle does m over 360 represent?
Percentage of. Distance of the arc?
The, either or, it represents the portion of the circle.
What page is this?
It's the page 867.
Okay, it represents the proportion of the circumference that you need, right? The percentage of the circumference that you need. What part of the circle does 2r represent?
Diameter.
Diameter, yes. Okay, so I want you to do 5 through 7 on page 868. I want you to do 5 through 7. 13 through, whoops. Oh, I guess I can write it on here. I want you to do 5 through 7, 13 through 16, 18 through 21, okay? And then on page this is page 867. On page 876. I want you to do 5 through 11, 13 through 18, okay?
Is that all it is?
Okay, so it's 24 problems, and you have an hour in class to do them, okay?
Okay.
So,
Yeah, let's see if I understand it.
we good?
Yes, ma'am. No.
So we like to listen to music and
Yes.
Wait, are we doing 7 and 6 or?
What?
What do we do with 7 and 6?
No, I was counting how many problems there were. Did you say you needed help? Were you serious? Were you serious? Were you serious when you said you needed help?
No, he was just joking.